In this video, we are going to find the equation of a line that is perpendicular to a given line. Now, in our last video, we found equations of lines that were parallel to each other. But in this video, the lines are going to be perpendicular. The process is going to be similar. What's going to be different is the slope. Now, with our parallel lines, those two lines had equal slope. That's what caused them to be parallel and not intersect. But with perpendicular lines, those lines have slopes that are opposite reciprocals of each other. Opposite reciprocals of each other. So the hardest part about working with perpendicular lines is going to be for you to remember that you have to take the opposite reciprocal of the slope of the line that you're given to find the equation of the line that they're asking for. We're going to go ahead and do the first example, and then we'll graph our given line and our perpendicular line answer, and then check to see if the lines really do end up perpendicular. So take a look at our first example here. And it says find the equation of a line perpendicular to the given line and containing the given point, right in slope-intercept form. So our given line is y equals negative 2x plus 3. So the given line is y equals negative 2x plus 3. So our first step is to find slope of that line, of given line. So we know that the slope is the coefficient of x. This line is in slope-intercept form. So the slope of the given line, m equals negative 2. All right, but that's not the slope of our line, because our line is going to be perpendicular to the given line. So step 2 is slope of perpendicular line. And we're going to use opposite sign reciprocal. So we have m equals negative 2 for the given, and then ours, I'll put ours. Our m is going to be the opposite sign, so that makes it a positive. So opposite reciprocal. So that's going to make it a positive 1/2. Okay, that's the slope we're going to use, and we're going to use this slope with the given point. So we're going to use 1/2 with the point 2, 2, which we're going to let be our x1, y1. And now we're going to use our point slope form, so we get y minus 2 equals 1/2 x minus 2. So that's our point slope form. Just a reminder to you that that one looks like y minus y1 equals m times x minus x1. Okay, that's a reminder. We've been doing several videos worth of work on that, but here it is. And now we're going to distribute that 1/2 so that we can get our equation in slope-intercept form. So y minus 2 equals 1/2 x, and half of a negative 2 is negative 1. And then we will add 2 to both sides to get this line in slope-intercept form. And we got y equals 1/2 x plus 1. Okay, we're going to take this answer with our given line and graph them. And let's see what it looks like, just so that you can visualize this a little better. Okay, so we're going to graph our given line. The y-intercept is 0, 3. I'm going to graph it in red. So 0, 3, and the slope is negative 2 over 1. So we're going to go down 2 and over 1 to the right. So down 2 and 1 to the right. And then we're going to draw the given line first. So here's the given line. Okay, there it is. Now our line has a y-intercept of 1. So we're going to have our line be blue. So there's 1. And the slope is positive 1/2. So up 1 over 2. So up 1 over 2, up 1 over 2, 2. And now we're going to draw that line. What do you think? Are they perpendicular? So now as you're looking at these two graphs, I just want you to see, can you see why they have to be opposite signs? If they're going to be perpendicular, if we have one line that's rising, the other one has to fall, doesn't it? So make sure that when you are working through these problems that you do that little visual check before you hit submit in your homework, that your two slopes should be opposite signs, because the sign is one of the things that gets forgotten sometimes by students, okay? One line will rise, the other one will fall, right? And then you can see here that by having those two slopes be reciprocals of each other, that helps us to get the two slopes to be perpendicular. So opposite reciprocals. Now let's practice some more of these problems. Okay, so here's problem number 2. Our given line is y equals 2/3 x minus 4. The slope is 2/3 for the given. So what's the slope of our line? It's got to be opposite, so that will be a negative. And then it has to be the reciprocal. So opposite and the reciprocal of this 2/3 will be 3/2. 3/2. So negative 3/2 is the slope we're going to use in our equation. And then the point is 2, -4. So in our point slope form, we have y minus a -4, y minus y1 equals m, using our opposite reciprocal, times x minus x1, which is 2. And now we're going to distribute. So we get y plus 4. And then here we have a -3/2 x. And when we multiply 3/2 times 2, I like that we're going to cancel those 2's, aren't we? We're going to get a positive 3. Okay, then we are subtracting the 4 to get this into slope-intercept form. So we get y equals -3/2 x minus 1. And again, a quick visual check that those two slopes are opposite reciprocals, and they are. Next problem. Okay, in this problem, our given line is in standard form. So our first step will be to rewrite the given line in slope-intercept form so that we can find the slope, right? That's the easiest way, I think. So that means that we're going to isolate the y. So we're going to subtract the 4x to put it on the right-hand side, and then we're going to divide by the -3, and then here's our slope. So m equals positive 4/3. For the given, that's given line. For our line, we need the opposite reciprocal. So we are going to use a negative slope, and then we're going to take the reciprocal of 4/3, which makes it a -3/4. And then we're going to use our point -3,2 as our x1, y1. And here we are in our point slope form. We'll take y minus y1, y minus 2 equals -3/4 x minus x1, which is a -3. And then we're going to simplify, distribute, right? So we have y minus 2 equals a -3/4 x minus 9/4. And when we add the 2, we are going to have to change that denominator to 4. So I'm going to go ahead and multiply times 4 to make it 8/4. And so now I get y equals -3/4 x minus 1/4. So notice that we just keep doing the same steps over and over again the last few videos. So hopefully you're getting enough practice in that this is starting to really get to be natural. So the only difference this time, those slopes are opposite reciprocals. You're ready to do number 4. So I'm going to show you number 4 and have you try it. So here's problem number 4. 2x plus 5y equals 6. And the point is -6, -8. And you are going to find the equation of the line that's perpendicular to the given line, but that passes through point -6, -8. So write those down and pause. When you unpause, we will have an answer for you to check against. Okay. Pause your video. So the slope of the given line was -2/5. So our line will have opposite reciprocal slope of 5/2. We used the point -6, -8. Solved for y so that we could get that point slope form into slope-intercept form, and got y equals 5/2 x plus 7. And then I was just doing a quick check with my highlighter that those two slopes are opposite reciprocals. How did you do? Hopefully you're catching on. So our last two problems are going to be those special cases again with the horizontal and vertical lines. So let's take a look at those real fast here. Okay, so now we have this vertical line x equals -1, and we want to find the line that's perpendicular to the vertical line, and that goes through the point 3, -4. And I really think that a picture will help us. So let's just draw a quick graph here so that we can visualize this. X equals -1 is right here. And we know that that's a vertical line that goes through the point -1, 0. So it'll look like this. So that's our given. Okay. And now let's find the point 3, -4. So 3, -4 is here. And now let's draw a perpendicular line, not parallel. So perpendicular line would go this way, wouldn't it? That would make a little 90-degree angle right there, which is the definition of perpendicular lines. They make 4 90-degree angles right there where they cross. And so this line is horizontal, isn't it? So you won't be surprised to realize that a vertical line and a horizontal line are perpendicular to each other. So we just need to find the horizontal line that goes through this point right here that we drew. And we know that that's y equals, and it goes through y equals -4. So that would be our perpendicular line. So again, vertical and horizontal lines are perpendicular. Okay, well that's going to help us out a lot with number 6, because number 6 is the horizontal line, y equals 6. So again, with a quick sketch, if it helps you, then use this, right? And you might have some graph paper handy, probably better, more accurate. But there's our line y equals 6. And then now go ahead and graph the point -5, -3, which is here. And because we're looking for a perpendicular line that goes through this point, perpendicular to that horizontal line, then we know that's going to have to be this vertical line right here. So what's the equation of this vertical line that goes through the point -5, -3? And that would be x equals -5. So again, vertical and horizontal lines being perpendicular to each other, we can use that fact to find these equations. I hope that helps. Keep practicing. You're doing great.